Good morning, students. Let us solve one more problem on bisection method. Perform 5 iterations of bisection method. 5 iterations of bisection method to obtain a root of the equation. To obtain a root of the equation f of x equal to cos x minus x into e power x equal to 0. Solution. What is the function f of x? It is a transcendental equation, cosine x minus x into e to the power of x. Okay, now whenever trigonometric functions are there, take x value in radians. Take x value in radians. Okay, that is change the mod to rad, radians, in calculator. Okay, remember this point. Then if I take 0 radians, this is cos 0 minus 0, this is 1 positive, and if I consider 1, this is cosine 1 minus 1 into e to the power of 1, and the value is minus 2.1780 negative. Okay, since f of 0 into f of 1 is less than 0, the root lies between what? The root lies in the interval 0 comma 1. Now bisection method, first iteration. What is the first iteration? Bisect the interval. What is the first approximate root? m1 equal to, first interval is what? 0 comma 1, 0 plus 1 by 2. 0.5 is the first approximate root. Then find f of m1. Substitute this root in the function 0.5 cosine 0.5 minus 0.5 into e to the power of 0.5. Okay, and the value is 0.0532. It is positive. Then second iteration. Since now f of 0.5 is positive, and in the first interval which one is negative? Where this is positive. F of 1 is negative, less than 0, and f of 1 is less than 0. The next approximate root lies in the interval. What is interval? 0.5 comma 1, and what it is? Bisect this interval, that is m2 equal to 0.5 plus 1 over 2, so this is 0.75. Now find f of 0.75, that is cos 0.75 minus 0.75 e to the power of minus 0.75, and this value is minus 0.8561. Now f of 0.75 is negative, and which is positive? F of 0.5 is positive, right? So third iteration. Since f of 0.75 is negative, and f of which is positive is f of 0.75 and 0.5. F of 0.5 is positive. The next root belongs to what interval? 0.5 comma 0.75, and is What is the next root? M3 equal to 0.5 plus 0.75 by 2. So this value is 0.625. Now f of m3, that is f of 0.625, cosine 0.625 minus 0.625 e to the power of 0.625, e to the power of 0.625. It is negative. You will get some value. This is less than 0. Next, fourth iteration, you calculate the missed values using calculator, okay, in your notes. Now this value is, since f of 0.625 is negative and positive is what in previous interval, f of 0.5 is positive, the next root belongs to what interval? 0.5 comma 0.625, and is m4 equal to 0.5 plus 0.625 by 2. This value is 0.5625, and calculate f of m4. What is f of m4? 0.5625. This is equal to cos 0.5625 minus 5625 e to the power of 0.5625. Okay, this value is also negative value, you will get less than 0. And the finally fifth iteration, see, all of you calculate this value and this value in your class notes, okay, when you prepare the notes using this video lecture. Now since f of 0.5625 is less than 0, and which is positive, f of 0.5 is positive, the next root belongs to what interval? 0.5 comma 0.5625, and is what? And is m5 equal to 0.5 plus 0.5625 by 2. This is 0.53125. This is the fifth root. This is the final answer. After 5 iterations, the approximate root is 0.53125. Now take 2 assignment problems based on bisection method. First one, perform perform 5 iterations of bisection method to obtain the smallest positive root of the equation f of x equal to x cube minus 5x plus 1 equal to 0. Answer is 0.21875. And the second question, find the interval in which the smallest positive root of the equation f of x equal to tan x plus tan hx equal to 0 lies. Determine the root correct to two decimal places. Correct to two decimal places using bisection method. Using bisection method. These two are the assignment problems. Assignment problems based on bisection method. Okay. Now the next method, iteration methods based on first degree equation. First degree equation. This is the next iterative method, and in this one, see, first degree equation means what? Consider first degree equation. What is that equation? F of x equal to a naught x plus a1 equal to 0. Linear equation, first degree linear equation. What is the solution of this equation? Take this as 1. Solution of this equation is what this is, x equal to minus a1 over a naught. This is, let it be equation 2. Okay, where a naught definitely not equals to 0 and a1, a naught not equals 0 and a1 are the arbitrary parameters or the arbitrary parameters to be determined by two appropriate conditions. Two appropriate conditions. Two appropriate conditions on f of x or its derivatives. Let me explain this. See, there are next methods are secant method, regular falsy method, Newton-Raphson method. All these methods are based on first degree equation. So the heading for this topic is iteration methods based on first degree equation. It is well known equation. First degree equation is a naught x plus a1 equal to 0. A naught x plus a1 equal to 0. And what is its root? X equal to a naught minus a1 by a naught. And what is a naught and a1? Two unknown constants. These two are. We have to find these two unknown constants. Two constants is always determined by two equations. How to get those two equations? If I give two conditions on f of x, or on its derivatives, I can determine the value of a naught and a1. Okay. Based on this a naught and a1, the methods were named like regular falsy method, Newton-Raphson method, and so on. Let us see now. The first one is what? Secant method. Secant and regular falsy method. Secant and regular falsy method. See, in these methods we need, in these two methods we need two initial approximations. So if xk minus 1 and xk are two approximate roots, then determine a naught and a1 in equation 1 by using the conditions. Since these two are the roots, we are considering these two are the roots, those satisfies the conditions, right? Xk minus 1 comma xk satisfies equation 1. Therefore what we have? Fk minus 1 stands for f of xk minus 1. This is a naught xk minus 1 plus a1, and fk equal to a naught xk plus a1. Here what is the notation? f of xk is nothing but fk, and f of xk minus 1 is denoted by fk minus 1. Now these two are the equations, and what are the unknowns here? A naught, a1, a naught, a1. So let us subtract these two equations. A1 gets cancelled. If I subtract these two equations, a1 gets cancelled. Then so subtracting those two equations, subtracting these two equations, a1 gets cancelled, a1 gets cancelled. Then we have a naught value, that is fk minus fk minus 1 by xk minus xk minus 1. Substitute this a naught value in any one, then a1 value is xk fk minus 1, xk minus 1 fk by xk minus xk minus 1. Okay, now substitute a0 and a1 in equation 2. What is equation 2? X equal to minus a1 by a0. That implies, so this becomes what? I will include this minus sign in a1. So this is, and xk fk by this, and this denominator and this denominator gets cancelled when I take a1 by a0. The remaining part is fk minus fk minus 1. Okay, now replace x by xk plus 1 to get next approximate root. That is xk plus 1 value is the root is xk minus 1 fk minus xk fk minus 1 whole by fk minus fk minus 1, or one can write in an easy manner, this is xk minus xk minus 1 by fk minus fk minus 1 multiplied by fk, where k is from 1, 2 and so on. This is these two formulae called secant method or chord method.